Hi everyone, in this video I want to talk about large language models, specifically why even the top performing LLMs today don't really know how to understand or reason with live data in the form of links online. As I'm pretty sure we're all well aware, LLMs have been extremely successful at understanding and summarizing historical data that's been scraped off the internet. So successful, in fact, that the best LLMs are now able to solve PhD level science questions better than 90% of humans. But one known problem is that when you try to scale this over to real-time data, LLMs they frequently respond with, outdated or broken links. That's been known for a while. And even though ChatGPT now can, interface and make searches online, that doesn't solve the core issue at hand, which is that with all of these huge advancements that have been made with the transformer architecture, LLMs at their core just don't really have the capability to reason with live data in real time. So, in this video, I kind of want to talk about the two main reasons why LLMs can't understand live data in the form of links, and then at the end, I'm going to give you like sort of a real world example of what the implications of this inability are and why it's important that we kind of bridge the gap between these developments that are happening with large language model technology and processing the massive stream of data that gets uploaded to the internet every day. So let's get into it. I'm going to start with the first big reason, which is training. So, if you know anything about what a LLM is, at its core, it's just a very complicated neural network, and you have to train its weights on a set of training data so that it actually knows how to solve problems. So that's pretty fundamental understanding, and this is the kind of pyramid of the different ways to train and interface with an LLM. So if you start at the top, that's pre-training. That's kind of, or sometimes called general training. That's when you start with like the base level neural network and none of its weights are updated and you need to train it from scratch. And that's typically very costly. Deepseek just came out and showed us all that it can be done for a lot cheaper than what Google and OpenAI were claiming. But even so, you're going to need over $10 million in hardware and at least, 2 months to train from scratch. Then the next step on that pyramid is something called fine tuning. That's a lot cheaper, and beyond that, you have RAG and prompt engineering, which I'll get into in a second. But why is this relevant to understanding live data and links specifically? Well, if you think about it, what is a link? It's a URL, and URLs, they're dynamic, they can change. They change a lot actually when you're dealing with a field or something that's updated constantly, like let's say an online market or e-commerce. Things are bought and sold every day. There's a link to every item. It gets sold, it's not going to be, so that link, it's not going to be there. One day it can be there, and the next it's not. Sometimes this is even less than a day turnaround. And when you're dealing with pre-training, it takes 70 days to train a model, and this is trained on static data. So you can't like feed the LLM new data while it's being trained. So what that means is if you're training an LLM on a data set, which includes links, by the time it's done training, you could safely say that over half of these links are going to be broken or outdated, which is kind of one of the first things that ChatGPT noticed when it came out and was giving users links. Then um, one kind of popular way to deal with that problem has been fine tuning. So fine tuning is when you have like the model trained from scratch, you have its weights, and you want to update them on newer, like a smaller subset of data in a quicker time. So fine tuning, because of advancements in LoRa adapters and quantization, fine tuning is actually very cheap. As opposed to over $10 million, you can do it yourself on your own laptop for like under $100 even in some cases. Definitely within a day or two, depending on the system you're using. So because of how efficient fine tuning is, for LLMs, it's kind of become like a catch-all solution to deal with live data or updating an LLM to understand more relevant data. But there is a key misconception that I think a lot of people forget, which is that when you have a model and you fine tune it, that doesn't replace the old info that it's already learned with new info. You're not like replacing the weights. What you're doing is you're taking your existing weights and you're updating them using this new training data, which is kind of what is shown here in this example. So why does fine tuning work then? Well, it works because if you have enough newer data, it's going to overpower, in a sense, the older, outdated data. But that doesn't really translate to links because, a URL is it's one string basically of data, and it's not associated much. You don't have much training data for it. So when you're trying to build a new fine-tuning data set using links, you're not going to get enough training examples pointing to a specific link to give it much meaning. And even then, the model can get confused and return the outdated links because of how similar they are. Um, and that's kind of like a core reason why fine-tuning hasn't proven itself to be a way to solve this issue with LLMs and understanding links. Um, and let's get into the last point, which is on this pyramid here, which is retrieval augmented generation, RAG. So what is RAG? If you look at this cost structure here, RAG's on the very right. RAG can pretty much be done in real time and it doesn't cost you anything. So that's like an even more cost efficient solution in some people's eyes. And let me talk a bit about what RAG does. So RAG is you have a data set or a database of data and you embed it into vector spaces. So you break up your data into chunks or respective pieces, and you kind of vectorize it to put it into a vector space in a meaningful way so that words or sentences or documents that are similar should appear close to each other. And then when you have a search, you can just go into that database and efficiently pull out like a cluster of closely related documents. Now, if you've ever used something like Perplexity, which is an AI-powered search engine, they this is kind of like the core building block of how Perplexity works using RAG. So you can theoretically you can have this data set of links. Actually, no, let me talk a bit more about this. So what is this? This is kind of a low dimensional representation of what it would look like if you embedded a bunch of text data. So this is kind of what I was talking about, where this is just for words, but it gives a very simple example. Um, Words that are similarly related are going to cluster close to each other. So if you search for something that's like, not specifically here, but let's say you search for a bathroom sink, your search would be very similar to this little cluster in the vector space, and you'd probably retrieve all this data, feed it into your LLM, and then you can say that your LLM understands this data in real time. Well, the problem is, how do you actually do this search mathematically? That's done with something called cosine similarity or Euclidean distance. That's when you calculate that's like a tool to calculate the distance between two vectors in a vector space. And you want to return the vectors that have the lowest cosine similarity to what you're searching. Well, think about what a URL would look like in this example. Well, a URL in most cases is just going to be a random string of characters. There's not going to be any semantic meaning. There's no way you can like get a group of similar URLs just based on the text that's contained in that URL. So that's kind of the key problem of why RAG wouldn't work. One potential workaround is if you did have like a key value store where you embedded all these keys, which are words that kind of describe what your link is, then search those keys and return the values. that's kind of like a more advanced solution. But even that doesn't really work because you're going to have to constantly update and re-embed this key value store to keep your links up to date and avoid the original problem, which is of your links breaking. All right, I hope that was a useful explanation of why it's hard to actually learn links directly with LLM training. But now let's get into the second point, which makes it hard for LLMs to understand live links, which is tokenization. So, what is tokenization? That seems like if you've heard of LLMs, this word will be familiar to you, but what it is when we're actually trying to train a model on a set of text data, they're not using like entire sentences or even words at a time. These words are going to be broken down into what are called tokens, which are kind of smaller chunks of words. And how language, how large language models like ChatGPT work is basically they'll look at the training data, they'll break it up into tokens, and they'll try to understand what the probability distribution of these tokens are. And that way, it's able to determine and generate what the most likely next token is in a sentence. And that's actually how, ChatGPT responds to your questions and how it's able to elaborate on existing ideas but using, new takes. That's like why ChatGPT claims none of its responses are plagiarized because it's always going to be probabilistically generating new next tokens. Well, and this is kind of like an example of what tokens would look like if you had this type of sentence in training. Um, and this approach, it's incredibly useful for capturing semantic meaning between different words or clusters of words. But if you think about what a link is, there's not really any semantic meaning there. Or even if you tried to tokenize a link, it wouldn't be very meaningful. So now I'm going to go on to OpenAI's tokenizer and show you what I mean when I'm talking about this. So OpenAI, for ChatGPT, they use something called byte pair encoding in their tokenization. That's not very important to this point, but I just thought it was useful to mention. And here I've inputted three different links into their tokenizer, which they use for 4.0 and 4.0 mini. You can find this on their site. And let's just see like how these links would get tokenized. If this is if we wanted to actually understand links in training for an LLM. So first I have a very general link, which is Portland Craigslist. And as you can see, there is some semantic meaning here. Every link's going to start with something like HTTPS, then colon slash slash. That's kind of semantic in that we know that that represents a link. Then you might have something like portland.craigslist. So if an LLM was learning enough, it would probably be able to understand that for Craigslist, first you have the name of a city, and then you have .craigslist and then .org. So an LLM would probably be able to learn something like this first link. But if we move into a more specific link, which is the actual cars and trucks search, like the first page of the search for cars and trucks in Portland, now it's starting to get a little more nebulous because this first part of the URL, there's some semantic meaning there, but then you have search. Okay, sure, that makes sense. It's like a word. But then you have, CTA, what's that? And then hashtag search equals one, and then tilde card, and then these zeros. So this isn't really like, there's no semantic meaning here at the end, and this would probably confuse an LLM, especially based on, how this is being tokenized. As you can see, it's kind of tokenizing one character at a time. And then when you have an LLM with its weights, like I said, it's going to generate the next token one at a time. It's never going to be able to like pull up a full atomic link. It doesn't know that one whole link is a link. It doesn't understand that. So it's just going to try to go token by token to like recreate what this link is. And you could understand that like but doing that in a probabilistic manner isn't going to be very successful, especially when you get to this third example here, which is an actual listing of a car. So this is like a 2019 Dodge Caravan, and there's a bunch of random numbers .html. So like if you ask ChatGPT, find me a live Craigslist listing for a 2019 Dodge Caravan, it wouldn't be able to generate that based on its trained innate knowledge. All right, now that I've covered, the two fundamental reasons why LLMs don't truly know how to deal with live data in the form of links, let's try to use an involved real-world example by going on Open Router. So this is a really useful site if you want to compare the performance of different models in real time, like in parallel. So I've got five of kind of the biggest names in LLM tech today, but obviously the free version because I don't want to pay. But let's try to stick with the car theme here and try to look up, find me the best deals for 2016 to 2020 Mercedes E63 AMG with under 50k miles. And I have web search turned on for all these, so like in theory they're gonna query the web for this, but they might even be able to pull up some links from their own data. Let's see how all these do and compare their performance. Okay, well, looks like one of these isn't gonna run, which is interesting. Which one was that? The Claude? Okay. Well, alright, I guess we're not gonna see what Claude did in this video, but let's start with GPT 3.5. So here we have a few links. It looks like it found three. Um, and what are these links? Looks like this is a link to, okay, well, yeah, so it looks like it got some live links here. Let's look at these more closely. What it is, it's not actually a link to the listing itself, as you can see from the bottom left on my screen. What it is kind of, it just went on Carfax and searched what I'm looking for. So that's kind of goes back to the example I showed with the tokenization, like that LLMs are going to be able to understand, the more generalized URLs. Like it's probably did the same for Auto Trader here. Like it looks like it's sending me just to their site, these three big names, the biggest aggregators, and just inserting what I'm searching for into those sites. Um, let's see what Gemini 2.0 did. This should be the best one because it's Google's. Let's see where it's taking me. Um, well, it didn't find any results. Looks like this one, yeah, so it's again from Carfax. So I'm kind of seeing a trend here, which is that the biggest, they're just going to return like generalized searches for the three or four biggest car search aggregators, which is fine. Let's see what R1 did. Yeah, so again, we have Carfax. It's looking to be the same general link on all these. If you look in the bottom left corner where there's the preview, um, it's giving me some good pricing info and some mileage. Like it figured out to get the right miles, which is nice. Now my screen's bugging. That's all right. Okay. Yeah, so this is kind of like what you would get if you went on cars.com yourself and searched for a Mercedes E63. It didn't ask for a wagon. And it looks like it didn't get the mileage range right. So yeah, it's not bringing up any useful live links in summary. Like what you would really want from a search like this is to give you kind of like a list of the best deals right now, which is kind of like what you would get if you searched on this yourself. Um, looks like here we have, no, this is just going back to cars.com. Yeah, so as you can see, this is four of kind of the biggest LLMs right now, albeit the free versions. And when you ask them to do a real search for using live data, it's kind of taking you to like these general sites and returning, a basic query using what you looked for, which is fine, but it goes back to the key issue, which is that if LLMs did actually have the knowledge within them to, compile a bunch of live data and live links, reason with them, see which one's a better deal, like, and then return an output, like a structured ranking of what the best deals are with specific links to where you can buy these cars, that would kind of be the best case scenario. And preferably from not just the same three sites, using like a very general search, which doesn't really match what I asked for. Now, let's compare, what this performance would look like if you're using like a dedicated AI system that has, a built-in ranking heuristic for actually looking up something that is within your domain. So if we had this same deal and went on something like C's, which is what you would use for domain expertise with live data for a specific field. Let's see what type of results we get here. Okay, so yeah, this is what kind of what I had in mind when I was searching on the other site, which is kind of a collection of listings to live sites or dealers. This is Concord Toyota. So yeah, this is like um, so this is kind of what the contrast would look like between an LLM with a more general or wide understanding versus a dedicated expert for one specific domain. Alright, with all that said, I guess it's time to wrap up this video. It turns out I've been talking for way longer than I anticipated, which sometimes happens, but what did we learn? So we see that, even with some of the best performing LLMs today, with web integration, they're able to do a very high level online search that captures some of what you're looking for. But even with that, it seems like LLMs are still limited by the scope and context problem, which comes down to the fundamental reasons of tokenization and how the LLM is actually trained based on the transformer architecture, which I talked about earlier in this video. What this means is that LLMs still aren't able to actually process, go over the entire scope of live links in runtime and reason with those in a way that's useful. And I don't think they'll ever be able to based on how they're built. It's just more of a general knowledge thing. To actually accomplish that, you need a domain specific ranking tool with some type of heuristic that's able to, process these live links in real time and also make sure that these links aren't outdated. I don't believe that that's possible for the entire scope of the internet in one place if you're searching for all types of things. But, and I think this is kind of validated by what we saw with Deepseek that just came out, which is emphasizing the power of mixture of experts models, where you delegate your response based on a specific expert in a domain. But with all that said, I'm still excited to see how this technology is going to develop. It seems like there's a new breakthrough every other week. So I'm going to stay tuned and hope you like this video and learn something. Thank you.